Hi, everybody. Hi, Travis.
Hey, Aaron. Good to see you.
You too. So thank you all for joining. I'm really, really excited about this conversation. I would be excited to kind of just listen in, and I'm excited to actually be part of it. So that's great. Before we jump in, I just want to say welcome to everybody and ask you to, this is going to be an interactive session. So find the chat window on the right side here of your hop-in window. There's a chat there, and if you go to the stage chat, that's where I'm going to kind of be looking. But first thing I want you to do, anybody who's here, go ahead and just like introduce yourselves. Give us your name, where you're joining from, and maybe tell us your favorite Python package. Just a good question to get started. And as we go along, we have a couple discussion items, but again, this is mostly going to be just an interactive Q&A type session. So if you have questions along the way, post them there in the chat. I'll be keeping notes of them, and then I'll kind of like pull in questions throughout the discussion as we do it. So a quick about Saturn Cloud. We're an end-to-end data science and machine learning platform. We are built around the Python ecosystem, specifically around like tools like Dask and Rapids for acceleration. And so I'm really excited here to have Travis Oliphant here. With many favorite Python packages. I'd say a couple of my favorites are probably ones that he has built or worked on or helped supported. So with that, Travis, I'll kind of just say welcome. And if you can just give us a quick introduction to yourself, and then maybe a couple of things that you happen to be doing these days.
Wow, yeah, that's a long, quick introduction. Let's see. Travis Oliphant. I'm in Austin, Texas. Been here about 13 years. It's kind of the business side of my open source development has been in Texas. I started in Python and open source as a graduate student over 20 years ago, and really fell in love with both open source development communities as well as the Python language to express ideas. I'm a mathematician by training and applied engineer, and but got really excited by entrepreneurship and business while a professor and a grad student. So I used to teach, been a professor of electrical and computer engineering, and then I've started and participated in a lot of open source communities and projects over the past 20 years, including NumPy, SciPy, Anaconda, Numba, Jupyter, Dask, and many others.
Great.
So now I'm still a startup land. I'm still doing startup. Now I'm helping other startups grow. So I've got a number of things going on right now, including Quansight, OpenTeams, and OSS.
Awesome. Great. Well, the first thing that because I've definitely seen your name as far as author of these packages, and I'm sure a lot of our attendees have too. A thing that I'm curious about is just kind of what drove that initial like creation of SciPy and NumPy and your initial work in those packages.
No, it's a fun story. I think it's definitely a defining story for me. I was a grad student at the Mayo Clinic, and I was developing, trying to determine derivatives of 5-dimensional data. So large data sets. We obtained the data sets from MRI and ultrasound, and we were trying to do elastography, which is shake the tissue with some sound waves, and then take an image using MRI or ultrasound of a propagating wave, then use that to infer stiffness. Kind of a cool technology and definitely fun mathematically. I was using MATLAB and C at the time to try to make that happen, and I was running out of space because MATLAB didn't have floats, and so they only had doubles. Just nascent support for floats, but it was just running out of memory, and so I kept looking around for something else. Found Python. And started to use it. And after a year after using it, I found I loved it. I really liked it. I could understand the code I'd written. I really liked the language. I really liked how it enabled me to do high-level thinking, but also exposed me to kind of this extensible system that was robust and clearly developed. Now, on the other hand, there weren't very many libraries for it. And so I kind of, as a grad student, young, naive, enthusiastic, and I said, hey, all we need to do is add a few libraries to Python, and then we can have this competitor and this massive open source free thing that everybody in the world could use. As a student, and still today, science is to be shared. And so it was hard for me to kind of write my code and then know that the language I was writing the code in, somebody would have to buy a license to even run that language. So I'm not opposed to proprietary software. First of all, I think it's fine to sell software, but in particular, software that people need to read, to write, to explore, and to develop, I felt should be more infrastructure and should be free. and available. And so I really wanted to kind of help Python grow into a space that all scientists could use. So that, I remember it was 1 year and I was a grad student, had some extra time. I don't know if I really had extra time, but I could kind of steal it from my, instead of taking 3.5 years, take 4.5 years to get my PhD. And I started the SciPy project. And there was 1 year I went back to the mailing list and watched myself kind of clearly just release one package after another. And they initially were, and then kind of combined together in something called multi-pack. And that drew the attention of a few folks. And then that kind of got me addicted to the open source ethos and the open source communities. Release packages, get some feedback from people all over the world, a lot of engagement with folks, and then they would improve it and help me improve it. And then it just sort of snowballed from there until I was just loving that interaction. It felt like the same kind of scientific interaction I appreciated and enjoyed. But it was pre-Facebook, pre-Instagram, pre-Snapchat. Some of the same things people get addicted to with the social media, we were addicted to in the late 90s and early 2000s. Was how we turned the internet on and people share with each other. The search devices were really critical to us. Google and Alta Vista, other search mechanisms were really critical to us to be able to learn. That's how we learned. That's how I could understand Python. That's how I could understand Linux. How I can understand anything. So it was really critical. So that's perhaps a long version of the story, but it gives you a real context and color as to why I did it. And then I went to after grad school. I was a professor immediately. I started to see the value of business, but I was so into the academic track that I got a job as a professor, but ended up spending a lot of my time writing software instead of papers. Perhaps I wrote papers, got grants, but really found myself enjoying the software development part. And kind of from as a professor, wrote NumPy, and I wrote NumPy to really save SciPy. SciPy was built on a package called Numeric, another package from the Hubble Space Science Telescope folks. They were trying to improve on Numeric, and it needed improvement, and they wrote something called NumArray, and libraries are starting to be written on top of NumArray. So I saw this split in the community. I saw, here's a SciPy stack, here's a NumArray stack, and instead of cooperating, people were writing individual separate libraries, and we were a small community, and so it felt like wasted effort. And so I spent a semester, I didn't have a class to teach that semester, and so I ended up writing NumPy instead that semester. And I thought it would just take me a few months. It did take me only a few months to write it, then another year to actually make sure it worked and engage with the rest of the community so we could get it released. So about 1.5 years later, NumPy was released, and it unified NumArray, Numeric, and helped start the process. NumPy is a hybrid product that definitely stands on the shoulders of Numeric and NumArray and all the great people that went before it. And one of the critical things about open source is that it definitely takes leadership and enthusiasm and passion from a core set of folks. It doesn't just happen by randomness. There's definitely people who have to promote it and push it, but it doesn't achieve critical mass and adoption unless you get the input and help of a larger group of people. So I often talk about the success we've had in Python with me and 1,000 of my closest friends, right? And it really does take that much effort to achieve the kind of spread that this has happened. And besides NumPy, NumPy achieved success because libraries like Pandas, scikit-learn, SciPy really did all the work to make it useful. Matplotlib, early day, Jupyter, all these things have been critical to the success. So it truly takes a community. And since that time, I really wanted to figure out how to connect businesses and how to make it sustainable. Because this is all done as a volunteer. This is all done in spare time. It was all done kind of sacrificing my academic career. And it felt like this is important stuff, but why do people have to sacrifice their lives to do it? Why can't this be sustainable? And so I've basically dedicated the past 10 years or so of my life still pushing technology, but also trying to find incentive structures that help this sustain and innovative in the business world.
Yeah, definitely. And when you look at packages like NumPy, Pandas, scikit-learn, they're so core to what so many people and businesses drive value with. And those are kind of free open source tools and like you said, built initially like volunteers and still to this day maintained by volunteers. And so and that's kind of like what we're talking about today is the fact that you don't need a lot of those specialized tools. You don't need to necessarily be a computer scientist by trade to actually, analyze data. And that's kind of where this idea of accessibility and democratization of data science comes from. And I'm curious as to kind of take this a little bit further. You know, we're talking about like the beginnings with NumPy, and then Pandas was a few years later. But how have you seen this data and AI ecosystem change over these last now like 10 years? And related to this idea of people who aren't computer scientists doing scientific computing.
Yeah, I think that's a really critical point. A lot of people kind of misunderstand both the power of Python and the power of development. And so Python was underappreciated for many years. I mean, I watched it early, and I was one of those early participants, a domain expert, basically, who really went to Python because I wanted to think about science, not development. And so there's this whole folks, domain experts, we call them. I call them occasional programmers, occasional developers, domain experts. They've grabbed onto Python organically and with enthusiasm. Meanwhile, there are still developers, and developers kind of have a different, they'll learn 5 or 6 languages in their lifetimes. They focus on development. They take computer science. There's a lot of really interesting things. I've learned more about that over the past 10 years than, say, I did in the early part when I was really focused on math and science. Then there's another group that's emerging, particularly today with the orchestration and DevOps and cloud. That's an IT sysadmin, right? And there's overlap between these groups, but I kind of call them data science, data engineering, data ops, you could say, as one framing of these different groups. But these different groups have different mentalities, tribes. They grow up in different ecosystems, and a lot of organizations, kind of power centers, can actually grow up that can interfere with the progress. You know, there's one group that ends up with all the budget, and they don't really understand the other group as well as they might. And I found a lot of value in Python and kind of bridging the gap between these tribes. You have the sysadmin tribe, you got the dev tribe, you got the domain expert tribe, and Python becomes a common language to unify them all. Now, even in the Python world, you'll see the little subdivisions, and you'll see that in lots of different ways as people don't kind of understand each other. Well, why are you writing the package that way? Or what does that do exactly? Or why should I use that instead of X? But this has been really beautiful to watch kind of that collaboration happen in the large open source ecosystem, and how it reflects and mirrors pretty much every technology organization will have these same challenges. So today, initially, it was sort of how do I write code that I can use? And Python helps you write code you can use. Today, it's I want to do machine learning. Well, machine learning requires, and AI requires, domain expertise to understand what's the model you're building. Why do I care? You know, development expertise, or at least somebody writing some package that I can embed that model in to run at scale. And then I need an IT organization that can orchestrate the systems to run. It's been exciting to see, for me, to see things emerge over the past just several years, only the past few years, where some of the operational requirements are getting more easy. Like, that's been a significant hurdle. When we started Anaconda, we basically came to market with one of the first cloud, something that was called Wakari. It was the first notebook in the cloud. And one of the intentions was to simplify for domain experts the ability just to get a machine and be able to work. There's a concept I think about that, you know, Bill Gates made a lot of money by bringing a desktop to a computer to every desktop, right? Kind of what the world wants today is a supercomputer behind every device. What people want is simplified access to massive compute capability. And we're getting there, right? But there's still some work to do, because, you know, you have your phone, you got your tablet, your laptop, and you want to have a simplified interface that has access to your data, access to massive compute, not just one machine that you might have on your desktop, but, you know, thousands of cores, including, you know, GPU cores that you can then quickly steer and orchestrate on your data, and do it in a way that you don't have to be, you know, an expert and a PhD in 3 different fields in order to pull that off. Today, it's still kind of hard. There's definitely, you know, Saturn Cloud, I'm excited about what you all do, because you do something, you make that simple. I think that's a really important key. So that's fun to see, and I think we're going to continue to develop that. And I think people are going to continue to enjoy improved ways to empower their data insights. I think one key thing that I saw just since 2015, and it really it made me very excited, because I'm one of these array-oriented warriors. In 2012, when we started Anaconda, and I started the project Numba, I saw the opportunity to do automatic parallelization if you focus on array-oriented computing. If you write your code with arrays and tables, data frames, and write at a high level instead of worrying about all the for loops and worrying about all the data accesses individually, different rows, if you said, I'm going to think at a high level, think about this chunk of data doing this, you could actually automatically parallelize that. And with modern architectures and modern hardware having so much, many cores, multi-cores, but you need to steer those cores with the right programs. And it's hard, it can be hard to do. But if we could write array-oriented program, we could do this. And so we wrote Numba as kind of a NumPy compiler to help people compile their code if they wrote it in an array-oriented fashion. That was exciting. And then what happened is it sort of focused on array-oriented programming, and all of a sudden the world paid attention. The deep learning papers that were published around the 2014-15 timeframe were phenomenal. And they got everybody excited about the potential for kind of automatic transforming data to models. And it just exploded, and a lot of investment. Many millions of dollars have been spent now on essentially creating libraries in array-oriented computing. So what used to be kind of a niche area, array-oriented computing, the NumPy folks, I'd go to companies and they'd be like, oh yeah, that's kind of cool. I see people are using this. The quant world, the finance world, the science world used it heavily. Kind of everybody else kind of looked at it and said, we'll do business objects, and they didn't really understand. It's been amazing to see kind of the whole world shift their attention to this array-oriented, and all of a sudden TensorFlow and PyTorch, these big projects, these massive projects have emerged. It's created some challenges because now in Python, for example, I wrote NumPy to unify a fractured array community in Python. That's why I wrote NumPy to begin with. And kind of the situation today makes that look kind of quaint because we have a very, very fractured world with lots of tensors out there now. And I think though we're in a better position to handle that because, well, one, the community is bigger, and so it's okay to have different implementations if the community is big enough to sustain all of them, right? And you can then learn from each other and you can make progress really quickly. So that's one. Two, we're doing better at data sharing. Like back in the day, numeric and num array, one of the challenges was you'd basically copy the data into a new data structure. And it was hard to do the data sharing. Today, we've made a lot of progress. We started that when I wrote NumPy. We also created the buffer protocol. We created extended buffer protocol to enable data sharing between two concepts. It's the concept I call fix it twice. Other people do too, but I like this notion of, hey, when you got a problem, fix the immediate cause, but also look at the fundamental cause and see if you can make progress there too. So we fixed the immediate cause by writing a single library called NumPy, but we also fixed the fundamental cause, fixed it. We made progress towards it by building a buffer protocol, and that's continued, and I think that's going to help the world too. So it's kind of a lot of different things I've sort of given you hooks to jump into, but I can dive into any one of those things if you like.
Yeah, absolutely. And I think that's a good distinction you made a little bit earlier on that, all these software tools to actually do the processing can be open source, but then when you can't open source like a piece of hardware, right? So then you need all of this infrastructure built around that. And then there are tools that end up costing money here and there. And so it's interesting interactions between all of these things. There is one question I do have some more questions that we can talk about, like tool specific and development stuff. And there was one that one of the attendees asked, and I think it's a great question to talk about, is to see a lot of these open source packages contribute to commercial success of companies like across the board, any type of company that needs analytics, right? And then even certain companies might even fork or get inspired from certain open source projects and create their proprietary solutions. Like, what are your thoughts around, first just that commercial use, and then how that money can potentially trickle back to the open source, but then also, just taking the open source itself and then commercializing that? Yeah,
it's a really good question, and the answer is long, actually. Yeah, there's a lot of things to talk about there. I think, if I highlight some of the points, I ended up studying economics as a grad student, kind of on my own. I ended up reading a lot about economics as a grad student because of this question. I could foresee the problem. I saw, we're going to write some code, people are going to be able to use it. What's going to incentivize them to not just essentially abuse it, just take it and not give back? And so that effectively started me on a journey to try to think about that and understand it. And lots of other people have contributed that question too. I mean, I feel the same sense of, unfairness of, wait, I wanted people to be able to share it. I wanted people to be able to use it. I wanted to have an impact on the planet. I didn't want to constrain people in ways that they couldn't understand. And it's one of the challenges. Anytime you put a constraint around it, you're basically blocking off use cases you haven't even imagined yet. So one of the advantages of a completely free licensing scheme is you allow people to create solutions that you can't imagine. And all of us are constrained in our understanding in some fashion, and yet we're interconnected to billions of people on the planet. And if we allow that interconnection to sort of develop unfettered, we get these amazing innovations. Now, on the other hand, if we don't somehow tie in the value created, the economic value created back to the innovation creation, we have a massive problem. I would characterize we have a massive problem today. We do, and it's still there. I've got some ideas about how to solve it. Actually, we're working on some of that. So I'd love to. It's actually what's been driving me for the past 10 years is to figure out. Okay, I want people to use the code, but I also want to make sure that that the value created can come back to the creators so they can continue to do it. Because it's been hard. It's actually been hard to see NumPy's success, but not have any money to do anything about it. Not have any money to fix the problems that are there. Not have any money to any support to. Since 2012, had a laundry list of things needed to fix in it, but tried to go get budget, but we went to different government agencies, and government agencies and lots of agencies want to fund the new stuff. They don't really want to fix the old stuff. Right. And so it becomes challenging in a world of how do I maintain this? So I've known about that for a long time. And I've given a couple of talks about ideas to think about that. And I've got a very particular approach called Fair OSS, and we probably won't have time to dig into it here, but please go to faiross.org. A couple of people, we're working closely with them. We've got a concept there that I think can actually create within a couple of years an entirely new investment asset class that allow us to actually steer investment money to open source and then allow the value captured by companies of open source to have it come back into the open source communities themselves. Call that a groundwater program, and it's kind of something I've worked on. It took me a while to come up with, but we're very excited about it. And I think it's going to take a few years to kind of come to fruition, but that's driving me right now is some of that. How do we do that so we can actually help solve this problem fundamentally? I don't think it's the only solution. I think it's a funding fabric. I think there's lots of solutions that will emerge, but it is something I care a lot about. I'll end on that section quickly by just giving people a scope of the problem. So I'm on the board of a mutual fund, and I understand something of the investment money that's out there in the world. I've worked in on investment banks. I've been consulting for them. There is $60 trillion or more of money people are trying to invest. Like there's a lot of money out there that people are saying, hey, I want value from this money. And it's your money, it's 401k money, it's your parents' money, it's savings account money. It's money people are saying, hey, I need to use this for improving the future, to earn interest. I need to make money off of this to support myself in the future. That's all looking for things to invest in. So that's the top funnel. Then you have on the bottom, you have this enormous, incredible open source ecosystem and ethos that's innovating. And it's taken over everything. Like every new innovation in technology essentially has some open source underpinnings. And that's been happening over the past 20 years. So we have this massive amount of money that wants to fund innovation, this massive system for innovation creation and technology, but they're not connected very well. Like the connection between those two is really weak, actually. You're starting to see it through some companies, starting to see it through some venture funds, but we need to do a much better job of connecting that funnel. And I think there's ways to do it. I believe there's ways to do it, and that's what we're working on. Is can we kind of reshape, create some investment? So that's what I'm actually very excited by that, and it's driving a lot of the next 20 years will be focused around how do we help that happen.
Awesome, yeah, that's great because these tools are like so foundational to how so many people drive value. We want to kind of make sure that they're also going to continue to be around, and bugs are going to continue to be fixed, and the new things can happen together. So absolutely.
Right.
I do want to kind of maybe change gears a little bit, and we can always continue down this vein as well.
Sure.
And we do have more time, but I'm curious specifically. There's a couple tools that I use day to day and that we use a lot and push in Saturn. I'm curious because I know that you were at Anaconda like around when Dask specifically came out, and that's a really exciting tool for me around parallel computing. I'd love to kind of hear a little bit more about the origins of that, and I think Numba might fit a little bit around in there too. But I'd like to hear about that.
Sure, you mean so like Dask and Numba and some of those the scalability work we did at Anaconda? Is that?
Yeah, absolutely.
Absolutely. So when we started Anaconda, we knew there was a problem of Python scalability. Everybody was using Python. It can be summed up kind of going to there used to be conferences around Hadoop. Like Hadoop was all the rage, right? Everyone was, big data and Hadoop and scalable computing. And all of the vendors in the conferences would be talking about their Java solutions. Meanwhile, all the talks were about Python users. And so it's this disconnect, and we founded Anaconda basically saying we've got to solve this scalability, this Python scalability problem, so that people can write their code in Python, but scale it to many machines. That's a difficult problem, and there's still people working on it, and it's still emerging. But we just jumped in. There's no lack of ambition, and so we jumped in to see what we could do. Got a DARPA grant to work on visualization around that problem, but also they allowed us to spend some of that money on 2 projects called Numba and Dask. So Numba was a compiler, again, to allow on a single machine use multiple parallel threads, and there's progress there happening now. Actually, Numba has a parallel range. It can run in parallel. There's P threads that can use. So you've got some scalability there, and it compiles to machine code, so it's very fast. You can write your code at a high level, and it's very fast execution. Dask was, okay, scale it even past one machine. How do I actually do this and enable thousands of machines to communicate, to solve a bigger problem, and to work on larger data sets? And so it was great. So we hired Matt Rocklin. He worked with the Blaze team, came up with a very good idea for a scheduler, kind of a distributed scheduler that was more like the Spark solution, but tailored and specific to Python. And then we funded him to work on that with a team of, we took all the money we were spending on Blaze and we moved it to Dask and said, we're gonna grow Dask. And so funded him for the first 3-4 years to enable Dask to emerge as a serious solution for scalable computing. Then NVIDIA jumped in. Then Matt left Anaconda, went to NVIDIA. NVIDIA helped to fund it, and then Hugo, who was there with us in Anaconda, founded Saturn Cloud to continue the effort around growing Dask. And I think Matt's now started another company to kind of also focus on bringing scalable Dask to the world.
Yeah, and it's really exciting to be in this space now with these with Dask itself being this Python native parallel computing. And you mentioned a lot of those kind of conferences before where all of the stuff was kind of focused on Java for scalability. And it feels very similar to the initial kind of beginnings of that distributed computing world, where we're seeing now more commercial support around Python native accelerations.
Yeah, exactly. I'm very excited about that because the simple reason that Java's fine. Java's a great language. It does the object and concurrency really well, but it's not great for domain experts. It's not great for numerical computing, and I knew that going in. I was kind of a vocal critic of the Hadoop ecosystem, and not everybody liked me because of that. But it was because simply my experience with working with domain experts and Fortran users and all the world. Like in the 90s, people said, "Hey, let's use Java for scientific computing," and it didn't work. They didn't do it, and so nothing had changed between the 90s and the 2010s and late mid 2010s. So I knew it wasn't going to suddenly switch, right? So we needed to actually expose other ways to make it work. Now, since then, Java has recognized that it can be a glue of native code, and then it can work just like Python does. But Python from the beginning has embraced itself as a steering tool, connect to the domain expert so they can use their English language centers to write code instead of having to learn developer speak as much. And if they use those language centers, then they can connect to low-level libraries, native libraries that actually do the fast code generation. And I still think there's a lot of work that can be done to improve that connection so that people can still write at a high level but have fast code emerge. I think there's still plenty of work to be done. So it's very exciting to see, and I think we have the next 10 years will continue with this trend as more heterogeneous computing comes into the clouds. Like one interesting thing about going back to our mainframes, which are now our clouds, is the cloud providers, we don't have to distribute the same hardware to everybody's machines, right? The cloud providers can experiment with parallel hardware and they can bring that to their customers much faster, as long as we can keep the developer and domain expert experience common, so they don't have to relearn how to develop every time a new piece of hardware comes out. Then that iteration can go much more quickly, and we can actually see, and I think we'll see vast improvement. One of the key things I've learned over the years is the key to innovation is iteration. Like the key to be able to do something better is to be able to do it quickly, like over and over again. Because it's not, none of us are out super geniuses. Actually, we all make mistakes. We all try something, don't get it wrong, try it again, and it's really that repeated trying again and learning from the, iterative learning from the previous experience that leads to progress. And so can we do iteration? And then the second key to that, though, is shared iteration. If I iterate quickly, can I then share what I've done with you so you can build from where you are, and then can you come back and can I build from where you are? So that reproducibility and ability to share my experience with a large cluster is really valuable. And that's kind of what we meant by accessibility is actually, and I think there's a comment thread. Susan asked a very great question about accessibility. Typically means helping other people who are impaired in other ways, and that's a really important use case. And I've done some work with people who actually really help that. Typically, we're using the word accessibility in a different context here. In this, we're just talking about enabling people who think about maybe their domain problem to be able to access compute capability more quickly and easily. So I don't want to. I think there's a lot of work still to be done to bring these tools to other impaired individuals. And I think that's possible. Right now, it's sort of like we're early days where we're barely bringing the tools to people who don't have impairments, right? So we're still struggling there. And so we need to do that, and then we can make improvements and important improvements for those who have hearing loss or sight challenges or other impairments.
Yeah, absolutely, and that's a good point, especially with overloading that term accessibility. So thank you for clarifying that. Similar to kind of what you were talking about. There's a question I saw that come in, and you were talking about just like usability, ease of use, being able to kind of write code and share it pretty easily. What are your thoughts about basically type safety and the trade-offs in building that in versus easily scripting and building out stuff in Python?
A great question. And this has been a constant conversation in the Python community. So I've been a spectator in the conversation for many years and formed my own views now at this point after watching Python get used both by small teams and also by massive teams. First of all, types are how you get speed, right? If you think about what a type is a translation of a concept so the computer can understand how to make it fast. A simple example: if I'm going to add two things, I'm going to add A plus B. Well, the computer needs to know: are you adding integers? Are you adding floats? Are you adding complex numbers? Because the actual instructions I execute are going to be widely different based on what the data actually is. But the user has this logical concept of its addition. I don't want the details. So types can actually help shield the details of compute from users. Now, on the other hand, because that user doesn't really want to care about types, they don't want to have to litter their code with type specification. So they want to write generic code that's just like, it's a plus. They don't want to put types everywhere. Domain experts hate putting types in their code. And so they want to write code at a very high level, kind of a typeless fashion. But to make it fast and for the computer to use it robustly, types have to exist. And so that question of how do I introduce types into this flow has been at the root of static dynamic typing wars, constant conversations about what's better and accessibility. What I found is the occasional user wants, they really like the dynamic typing, really like the ability not to have to specify their types and be able to just get variables that refer to data. And then however, if you have a large team working on code and you're trying to refactor code, types are essential. It really makes it difficult if you don't have types to understand, okay, am I still safe here? Can I rewrite this code? What was the intent of the original code? And so I've watched a lot of folks with 1,000-person teams on a code base kind of struggle if there isn't types. And that's actually what convinced Guido to add, when he worked at Dropbox, to add type annotation. And so that types initially could be used as just simply a communication device, a documentation mechanism to tell people, well, I'm tending this. So you could do what's called linting, which is analyze the code before it's run to see if someone's made a mistake on type intention. It doesn't change the runtime of Python, but it does allow you to kind of run a prepass. With Numba, we added something called type inference, which is a well-known way to take somebody's code that hasn't been typed, but when it executes, take the types that are passed in, infer what types are the other variables are that are involved in downstream functions, and then take that type information, append it to the code in order to compile the actual machine instructions that are going to run. And that's going to produce much faster code than if you have to interpret every single instruction. So it's complicated perhaps, but there's different stakeholders, and the different stakeholders have different needs. And again, this is where Python has shined in the past. And I think with the addition of type annotations and gradual typing capabilities in Python, it's going to continue to shine in the future.
Yeah, definitely. I mean, I find myself now trying to always make sure I put in the types when I'm writing my code, and it helps just when I go back and read it later, or like you said with Lin.
Correct. I think there's an important workflow here to talk about, because when you're exploring data, you're experimenting, you're trying to come up with an algorithm, the types get in your way, and you just want to think about the data. You want to think about, I want to do some operations, I want to get things working. Now, as you get stuff working and you want to operationalize it, put it in production, make it so you can reread it later and other people can use it in the future, that's when the type annotation becomes a part of the hardening or the productization of the operationalization of your experimental code. A lot of people would take their experiments and have to then say, I'm going to rewrite my code. What we found in the Python community, you don't have to change the language you write it in, but you might have to harden your code. You might have to write, here's some experimental code I wrote. I want to now use it in production. There's some things I might do, like add type annotation, add logging, add checks, add things that make it more sustainable and reduce the technical debt so that others can modify it later and can consume it later for and update it later. So it doesn't just become this black box of impenetrable code that you wrote at one point. Nobody knows how it works anymore.
Yeah.
So it's adding documentation, adding types. That's this hardening process that all the software engineering people, the key thing to recognize is you don't have to change the language to do that.
Right.
You don't have to rewrite a different language. You can just add these things.
Yeah.
And that's becoming more and more easy to do.
Yeah, especially with the packages now for parallel computing, accelerated computing. Now you don't even, if you need it faster, you don't even have to leave Python either. So.
Yeah, exactly.
That's great. One other question I had is we have been kind of talking about and throwing out so many package names, and even someday I remember had a question there about, like, can you spell out the packages, because we're saying so many, and maybe we're used to saying them, but then people who aren't used to them might not know them. But that's like, it's like a great problem. I feel it's like a good problem to have in Python, the fact that there are so many awesome packages that people are building. How would you kind of speak maybe to new users or help recommend for people who are trying to sift through all of this and kind of try to find the right things to use?
Yeah, that's a great question. It's the curation problem, and it's not an easy one, frankly. You kind of go to you basically find is there's often the search is just Google can help you because it'll give you the most popular packages. Yeah. If you arrays in Python or tensors in Python. But it's gotten harder, honestly. I think this is where leaning on a distribution like Anaconda can help. Go to anaconda.org and then say, I'm going to go get my Python from a curator of Python packages. Mm-hmm. So I don't have to myself go stitch together the best, latest, greatest. Anaconda is doing that for me. So that's one approach, is use a curator like Anaconda to go and get everything you need. And then kind of go from there, see what they included. Oh, well, they included this. Okay, why? This must be good. Then it's kind of a crawling concept. You go to the pages of each of those individual projects and then try to understand, then say, well, what do these rely on? And then kind of you can filter out from there. I think the conferences, going to the PyData conferences, going to SciPy, going to some of these places where people hang out, and you can sometimes do it just there's Gitter channels and there's other channels where people hang out. But going to the conferences and just listening in, you get directed towards interesting projects. People will talk about the projects they're interested in. So that's definitely one as well. If you're in an organization who's trying to use these open source packages effectively, then I'd like to suggest that you come to OpenTeams.com. OpenTeams is our new venture, right? Whose purpose is to basically help people navigate open source in general. The problem of open source in general, and it's definitely true in the PyData ecosystem, is there are millions of open source packages, and finding which ones to use, as well as finding experts in those packages, is a big problem. So that's what we're taking on as well, is in a very near term, helping connect. I've done a lot of work over the past 12 years in building services firms around the NumPy and Pandas and scikit-learn space. That's what Quansight is. It's what NThought was. It's what Anaconda started as. So we've done a lot of work doing that, and I've learned a lot along the way. And I want to help hundreds of people build the same kind of services firms, and then have a place where you can kind of come and curate so a company doesn't have to navigate that field. They can go to a common marketplace and find solutions. So I think there's still work to do there. I'd love to see. I like the work that the Read the Docs folks do. Read the Docs is kind of in a place where they'll go, and a lot of people use them because it's a common, like Dask has their docs there. There's a lot of docs there, and that can be a place you can kind of browse and find things as well. So it's not a solved problem, I would say. It's still, it's one that I hope to see improved solutions in the future, but I think it's still something that, so it makes it kind of fun in the sense that it's still a place that people can learn and contribute, and you don't have to be, a 20-year veteran of the space to actually make a significant contribution leading somebody to a cool package that you found. So that's kind of fun.
Yeah, and then you can create value in much in the same way as like maybe when you started, and that community is still there and receptive rather than being kind of stuck on a handful of proprietary tools or anything like that.
Yeah, exactly.
That's great. Actually, so there's another question here. It's sort of related to typing, but I think maybe more general to Python is somebody's asking about like how the JavaScript community has a lot of kind of like extensions like TypeScript and other things, and why do you see Python having that? And I think there's probably something else that you might want to talk about in that area. So I'll let you take.
Sure, absolutely. Yeah, your softball for me. Thanks. So this is very fascinating. I totally understand some of this because Jupyter is engaging with TypeScript, and so I've learned a lot about TypeScript over the past years, and I'm really impressed with TypeScript. I like it quite a bit. Even when we started Anaconda, we recognized that the world was moving to the web, and I had a project with Microsoft actually to bring NumPy to C#, right? To bring NumPy to the CLR. That project was started, but the minute we signed it, that Microsoft had just started their transition to focus on JavaScript and like push a bunch of stuff to make sure their platform was deeply connected to JavaScript. Then they created TypeScript and kind of went from there. So they've been focused. We saw all the big majors focused a lot of money and attention on the JavaScript ecosystem, and things like TypeScript emerged. So Python hasn't enjoyed the same attention for until roughly 2016, right? In about 2016, we have started to see this kind of activity, but not, I would really love to see language level focus. I think part of it has been framing. How do we solve this problem? Because Python encompasses so many user stories that framing the problem of typing has been challenging. But I would say MyPy and MyPyC is exactly in this space. I recently have made a proposal and kind of started work on a project I'm calling ePython. And currently, I'm actually just looking for funding for ePython. So my view is we need to get all the investment that went into TypeScript, all the investment that went into these tools in the JavaScript ecosystem just haven't existed in Python yet. We start to see it in things like JAX from Google, and things like the PyTorch itself and TensorFlow have deep JITting capability internally, but they're not language level. They haven't risen to language level yet. And I think we can. So there's a project called ePython, and it's ePython dev on GitHub. So it's very development stage. It is definitely not for prime time use. Nobody should go thinking they're going to get a solution to a problem they have. The only people that could, but if you're interested in solving this problem, it's like we're creating a TypeScript for Python. The purpose of ePython is to basically create a subset of the Python language that's typed that can be used to extend Python itself. So having written dozens of extension modules to Python, NumPy, SciPy are extension modules, I know how you extend Python. And one of the challenges of the Python's future is that currently all extensions to Python use the CPython API, right? And so that actually is powerful, but it limits the ability for Python to go to different platforms like the web, like mobile, like embedded in some other application. What we need is to basically, I think we can now with type annotation and the work of MyPy and MyPyC, we can create a subset of the Python language that is how you extend it. So you could write NumPy in this. There's a project called Cython that came before, and that's how come I know we can do this, because Cython exists. And Cython would be like, if ePython can emit Cython, it has the CPython backend. We just need to write backends for WebPython and for MicroPython and for Jython. So I think I'm very excited about that project because it's like my Numba. Numba was my 2012 excitement, and this is my 2020 excitement is ePython. So hopefully in 3 to 5 years we'll have something significant there. And there may be other things that emerge too. I mean, there are people working in this area, so I'm excited by it.
Yeah, and actually kind of along these kind of language discussions, I think someone had a question here about Julia. I know Julia is also like a NumFOCUS sponsored project, and what are your thoughts there on?
Yeah, no, absolutely. I've met the Julia creators, love them. They're great people. I learned a lot. I mean, Numba has a lot of features because of Julia, I would say. Going back to the reasons, the fundamental reasons why in TypeScript and things exist and not in Python, I think it really comes down to the fact that so many of the companies that invested in TypeScript, they're kind of led by the domain experts, led by developer IT people. I've actually been so much surprised by the lack of understanding of the domain expert problem in some of the large technology companies. I've talked to many leaders there, and they're so driven by developers that they sort of don't understand as well as they could this domain expert cause. And so given the domain experts have really what's brought Python to prominence, it kind of, I think a lot of the developer focused language development, they kind of lost focus on this group. And so it's like, oh, I'm a developer focused. I'm not Python. Why am I going to fix Python? But as soon as you're thinking, well, the domain experts are all in Python, I need to help them. Now your attention's drawn there, but it just hasn't been until roughly probably 2016, 17. So I think we're still just early stages, whereas JavaScript got attention in 2001. Like when did Brandon create JavaScript? It was early. It was many years ago. And so I think it's history. I think it's some of the cultural questions. Julia is kind of a similar situation. Julia was created for domain experts. It was created as a replacement for MATLAB. I would say I love the Julia folks. I love what they're building. And I think it's challenging to build a new language and capture hearts and minds. It took Python 20 years, right? Some of this just takes time. No matter how awesome it is, it's going to take time. I would say I've encouraged the Julia community, and I continue to encourage them, become the best way to write a Python extension. Right, that's rather than try to be your own main language, become the best way to write a Python extension, and then you get a whole bunch of users. And I realize that kind of goes against the grain. Like, no, I want all people to use Julia. It's like, well, I think we're past a world where a single language is going to dominate anything. A domain expert might just use that language, but you need to integrate. And getting all domain experts domain experts kind of learn one language, and then they don't really want to learn another one. So every new domain expert that learns Python, you're kind of like, okay, are they going to go and learn Julia? Well, maybe, but maybe not, because they don't really like learning new languages. So that's one challenge. It's got great technology, but I think there's just some inertial and human challenges in order to achieve their goal. The other thing I would say is you write different code. I talked about this gradual typing from high-level no types to low-level typed. It's still unclear to me, and you certainly shouldn't do that at runtime. And this is one of the things. You need an infrastructure. You need precompiled libraries. You need stuff that's already existing you can call to. You're not going to write all code and have it compile on the fly at real time. And that's one of the things Julia allows, but kind of doesn't have enough infrastructure around to not force you to do that every time. Now it's changing, it's growing, it's improving. But that was when I first started using Julia. It was like, oh, I'm importing. When I built SciPy, SciPy can take half an hour to an hour to build, right? I don't want to do that on import time every time I'm running code. So, but I think there's some amazing things Julia will continue to do, and whether they achieve, I think there'll be a language that's around for a while and there'll be many users. Whether they achieve kind of, they overtake Python or not is to be determined. I actually suspect that we'll be able to make changes to Python to bring the features of Julia to mainstream faster, but I could be wrong about that. And mostly, I think, try it out, see if it helps you, and let's work together in a polyglot world. That's my view.
Yeah, absolutely. That makes a lot of sense. And so we only have a few minutes left. I kind of want to give you some opportunity too to talk about some of the things that you're currently working on. I know you've discussed some things like OpenTeams and OSS and ePython, but maybe other things that you're excited about in the Python ecosystem, or things that you're specifically doing.
No, sure, for sure, definitely. Yeah, I've no lack of excitement. I mean, I've always trying to push the envelope, and for me, it's actually technology and people. So a lot of things we're doing, the way we do it is I can't do it alone, and so I'm trying to grab, motivate people, and also then improve certain technologies. One of the things that Quansight Labs has been doing. So Quansight has an open source research component called Quansight Labs. It's a nonprofit segment of our Quansight services organization. Rolf Gomers heads that up. Tanya Allroyd is going to be a co-director. She's going to come soon. Very excited about that. They're working on something called data APIs. If you go to dataapis.org, you'll find this is our sort of NumPy mission. Like NumPy helped unify the world back in 2006, 2007. Data APIs is intending to create a common API for the Python array libraries and data frame libraries to use, so that downstream developers can write to an API and not be forced to choose a library to work with. They can use a concept and then let any library that implements that concept be used in practice. So the hope is we can, that's just gotten started. It got started this summer. They're about to publish their first API version for arrays, and the data frames will follow quickly. And you know, it's a consortium. It's an approach where companies pay to help attend meetings and help to pay for the development of the API. And if you're a company like to participate, or a person who'd like to jump in, go check it out. Excited by that. Excited about ePython. OpenTeams is more in the space of setting up a framework and an initiation framework, helping people grow service companies. So I believe there should be thousands of service companies. There exist hundreds today. I want to help create even more and then unify them in a common marketplace. So that's a current business venture we're involved with, openteams.com. If you need help with open source, go there and we can connect you with the world's experts who can help you get solutions quickly. And then I've got, of course, creating a new asset class with FairOSS.org. That's an even bigger, broader concept that we're trying to promote. And that's being led by a couple of folks who are really pushing that hard, and I'm excited to help them. And long term, we've got a little venture fund we've started, right? We're going to initiate because I want to help people take open source that they've done and build companies from it. And there's lots of ways to do that, service to product companies. And I really want to be involved, sharing whatever knowledge I can. I'm really motivated by helping people. It's driven me for 20 years, and I continue to be. I'm just delighted when people succeed and people build things that others need, and I want to share whatever I can to help people do that. So that's what we're doing. We're about Quansight, OpenTeams, FairOSS. It's different aspects of the same fundamental desire to use open source to continue to change the world and continue to bring us together.
Great, and there's definitely sounds like there's a lot of things that you're focused on, working on, and we've been dropping links throughout the chat here of everything if you want to kind of keep up with what's going on. I want to ask too, just like, do you see future happening around, or what would be happening right now around like Jupyter specifically? Because I know that's a tool that a lot of data scientists use to kind of access all of these packages. You know, what are some exciting things there?
Yep. Yeah, Jupyter is exciting. I'm excited that we've just, Eric Charles has joined Quansight to lead our Jupyter practice. And we've got a bunch of people there who are helping to move Jupyter forward for clients and companies. JupyterCon just finished. We announced a project called QHub. QHub is our open source kind of technology infrastructure. It's sort of the best. What we want to do is pull together the open source solutions that make it possible to scale, and you can build a platform upon. We use that as a starting point for all of our customer engagements. JupyterCon brought together people, and I think the future of Jupyter is bright, but there's a lot of, there's some developers, it actually illustrates the problem of IT developer and data science perspectives perfectly, because a lot of domain experts love Jupyter and want to just stay in it. They want to build solutions with Jupyter. Developers look at Jupyter and go, oh, that notebook out of order execution, what is that? How does that work? I gotta have an IDE, a code editor. So there's kind of, okay, but how do we help domain experts write their code, then maybe give them tools to transition to something that can be developed further and then deployed? Like, where many people see conflict, I see opportunity. And I think that's the Jupyter community will actually come up with amazing kind of solutions around that space, because it brings people together. We're trying to solve the same problem fundamentally. So I think Jupyter has a bright future. They're working on some governance issues. Jupyter's gotten big. One of the challenges of open source projects, they grow, is who leads them. Like, who decides what happens? And I've made a distinction in my writing called community-driven open source versus company-backed open source. And the difference really comes down to governance. Who's in charge, right? Because company-backed, you can at least see, well, the company's in charge. And there's kind of some clarity there. There's some cons there. There's some pros there. Community-driven is where I've spent my life and my focus, and done some company-backed too. But community-driven, I think the issue there is really, well, what happens as it scales? How do we get consensus? How do we bring together people to know where the progress should be from the multi-stakeholders? And every project goes through these growing pains, you know, from a small group of people that make it work to begin with, to a larger group of stakeholders, and how do they all agree to move the project forward? I think there's still work to be done there, and you know, people are doing great work to make that happen in Jupyter as well as other projects.
Awesome. Well, I think we're just about out of time now, but Travis, again, thank you so much for this. I think there was a lot of great insight. We had awesome questions from the attendees, and I enjoyed this conversation a lot. I learned a lot, and hopefully everybody listening did too. There was a couple questions in the chat. Well, we are going to have a recording for this, so we'll make sure to kind of share that out to everybody afterwards. But just wanted to thank you again, Travis.
Absolutely, my pleasure. And if anybody wants to be in touch, you can find me on Twitter at TE Oliphant. You can find me on LinkedIn. Happy to reach out and message you. Travis at OpenTeams.com. I really do would love to answer your questions or engage with you as I can, but really appreciate the questions from everybody and love the questions, Aaron. It's a great conversation. Really enjoyed it.
Yeah, I did too. Likewise. So thanks again, everybody, for joining. Like Travis said, you can email him there. Find us on Twitter if you have any more questions. When Saturn Cloud does have community Slack too that you can join if you want to kind of keep the conversation going. So thanks, everybody.
Awesome. Thanks, Aaron.